The goal in Network Plus is really to begin to understand the diagram that you see in front of you, where you begin to see the various components more independent from one another, such as the interface from your ISP, and then your router as a separate device, then your firewall as another separate device, maybe even a NAT VPN server, then a more enterprise type switch and workstations and access points and servers and printers and things of that nature. So in this case, at home, you don't have this. You have this all-in-one little $40, $50 box that you buy from D-Link. But we want to take that home environment and begin to springboard into understanding a business network. Most of you should be very comfortable with the picture that you see. You typically see your DSL cable interface box, your Ethernet cable, and then your most common SOHO router, which we've learned in our A+ studies that this is a multifunction device. It contains many logical components that make up a network, such as DHCP server, a WAP, firewall, NAT, things of that nature. A small switch is included, and this is typically what people have at home. Your telecom and ISP will provide you a simple DHCP IP so that you have an internet addressable IP address. And this is the type of structure that you're comfortable with. We want to use this same environment to build your understanding of a business network. So let's begin with the realities of a business network. Some of you are going to get hired and you're going to go into well-designed and complex networks, structured, and it's going to be quite a challenge to learn them and grasp all the elements of that network. Some of you are going to go into a business where it's just chaos, but it works. And you're going to see things like this that are going to absolutely blow your mind. So you can expect neither one of these are necessarily non-functional. I would hate to work here, but this is reality in a business world. We want to begin to understand a business network so that no matter which business we go to work for, we can understand and work with that environment. Let's go over our learning goals. We're going to understand the logical components of a home network and their relationship to business networks. Explain the roles and functions of each component, and we're going to configure and troubleshoot a small business network. We're really going to move out of the home equipment into more of a small business equipment. So you will see that big transition in NetPlus. Pause a minute and look at your scale here. Are you a 4? Are you a 3? Are you a 2 or a 1? Our goal is to get you at least up to a 3 by the time you finish this lab session, the videos and lectures, and review your notes. Our goal is to get you to a 3. So here we are back with a home network. And let's talk quickly about some of the trends that are taking place. If you'll notice, we've got our DSL modem cable, we got our Ethernet that connects between the ISP device and our home router. And then we would have computers connected up to the switch. But today we're really moving to wireless. So most of our devices, we have Android phones, iPhones, tablets. The access point, the WAP portion or the logical function of the WAP is becoming more and more critical. So if you don't have an NWAP or an AC WAP, you're really hurting in terms of a wireless configuration. We're moving away from less and less wired to more and more wireless. Just be aware of the trends now. Another trend that's taking place is the ISP is bringing all of this maybe in one component, and they're providing everything, the interface, the wireless access, the router functionalities, and all the logical components inside. So that's taking place, and that makes sense because a lot of home users are not technical, and setting this up and configuring them is beyond them. So a lot of providers now, ISPs, are delivering everything, a turnkey solution for the home user. So here's some ISPs in the Winter Park area, Winter Park, Florida. Our big provider is Bright House, CenturyLink, which is a telecom, and we're going to talk about this. This is a PSTN network that is providing internet services to home users and businesses. We also have AT&T locally and a few other small cable providers. But your area and where you live, that may differ. We'll take a look at each of these. When we look at the purpose of ISPs at home and a small business, there is no difference in their provision to the small business as to your home. They provide the last mile and the internet infrastructure, the cabling, the fiber optics. They provide typically DNS services for your small business and the complex routing switching infrastructure that connects you to the internet. So they also provide a usable IP address on the internet to your business. This you may, in a small business, you may get a static IP address. You may get more than one IP addresses depending on the complexity of your small business. Most home users are going to get a DHCP usable IP address. The larger the business, the more likely you're going to get static IPs, maybe even addressable, a series of IPs. This is a diagram of internet services. Most cable companies are kind of proprietary and they don't like to divulge their infrastructure design because of competitive reasons. But this is a good diagram, and it gives you some idea of the complexity to bring the last mile to your home or to your business. You can see there are many things involved. We've got amplifiers in a cable system. You've got amplifiers throughout a neighborhood. You've got street cabinets that where all the runs from various homes are brought back and brought back to a central location and probably re-amplified. You have multiplexing stations where multiple homes are brought together and then multiplexed into one signal, and then long haul fiber optics to, say, their data center or their local regional area. This is very, very complex. The sophistication of the networks and the equipment and the cost are enormous. It is not easy to do this. If you're a cable provider, you're going to also have to connect your cable infrastructure to a PSTN network. That's your public switched telephone network. So if you're providing voice over IP to these homes and businesses, you have to take your cable system, your network infrastructure, and eventually connect it to some PSTN. The PSTN regional providers in our area here in Florida are going to be primarily CenturyLink and AT&T and some of those type of PSTN providers. So you're going to, even if you're Bright House in our area, you're going to have to connect and negotiate contracts and physically connect your network with a PSTN provider so that they have telephone services. This diagram is simplistic, but you're talking about millions of dollars worth of equipment, personnel, etc. These are extremely complex systems. So let's take a look at a PSTN ISP. This is a public switch telephone network. This is typically CenturyLink, and in the area that I live in, it's going to be AT&T, CenturyLink. These are the old style public switch telephone network companies that are wanting to compete in the area delivering the last mile. They are doing it through DSL. So generally, they're going to either use fiber optics and convert it to Ethernet, or they're going to bring DSL to your home. They're just as valid. Generally, they cannot do as good a job with high-speed delivery of internet as a cable company can. But let's take a look at how they do it. It's very complex. It requires a lot of money and a lot of highly skilled technical people to do it. They start with the central office, and let's highlight this. This is the key to all PSTN networks, and this is the building located throughout your city or your area that houses all the equipment that makes PSTN work. In it is obviously telephone company equipment, but in order for them to provide internet access, they're going to be using a thing called a DSLAM. And that is a digital subscriber line access multiplexer. And that's going to be inside the CO. This is going to be equipment inside the CO. And that's going to take your signal from your home, the home device that you have in your house, and that DSL interface box. And that's going to allow them to bring all these home users into that DSLAM and then connect it up to a internet connection at some point. But you can see we're going to have street cabinets, joint boxes, obviously telephone lines. It's a very complex system for both cable and your PSTN ISPs to deliver last mile. PSTNs were always known for POTS, Plano Telephone System, Plano Telephone Services. And as we move to cell phones, this area has really lost its shine and vigor, and at least the home market. And even we're going to see that that is really moving to voice over IP even in the small business. So the whole idea of plain old telephone service is really declining, whereas the demand for voice over IP and internet access is continually increasing. Another element of your ISP that you need to be aware of is the cost and the speeds of internet access that are delivered. For example, in my home area, the home user is able to get up to 90 megabits per second with a cable modem provider. That's pretty good. This cost is relatively inexpensive, but if you were to go and ask for this same amount of internet speed at a business, this would be pretty pricey because business cost will be substantially higher than home cost. It's not that it costs them any more to deliver the service and the speed. In my home, I could wait 2 or 3 days for a service call. In a business, usually it's going to be the same day or the next day. And so that's where that cost drives up. So let's take a look at our physical connection. If it's a cable company, typically it's going to be a coax cable. If it's going to be a PSTN type ISP, a telco, they're going to bring DSL signal, typically your telephone line. Some have fiber optics. Verizon brings to their subscribers fiber optics, and you're going to have some kind of interface box with that. Now, there is some wireless providers that provide a wireless device that can become a wired access point in your home. They're pretty pricey, and the bandwidth is not very good, but that is also available. Here's an example of a complex piece of equipment in the cable infrastructure. Cable, if you're connected to an ISP that is cable-based, this is a CMTS, and it's a cable modem termination system, and it combines a traffic of upwards 4,000 to 150,000 home interface boxes to the main head end of the broadband provider. People pay probably $2 million a pop for this type of equipment. So this is the complexity that makes it work. If fiber optics is being used by the ISP, you can see some of the components and the major elements. You've got your line amplifiers throughout your neighborhood or your business zone. You could have a commercial business zone and have the line amplifiers, keeping that light to a level that sustains good visibility through the fiber optic cable. Trunk amplifiers, optical nodes. You got multiplexers and distribution hubs and all of this, and then of course your head end. So this kind of gives you an idea of what is taking place, whether it's coax cable, whether it's a PSTN provider, or it's fiber optics being delivered to your home. It's very